All right, everyone, buckle up because we're diving into something we're swimming in every single day but rarely stop to think about. How does the information age, you know, actually happen?
Hmm. Good question.
We're talking data acquisition, the often invisible process of pulling real-world data into the digital world.
Right, right. Like, imagine for a second your smart thermostat with no clue about the actual temperature.
Or your streaming service with zero movie
This would
recommendations.
be chaos. That's life without data acquisition, my friend.
And to be our guide through this kind of invisible world, we've got this article by William L. Weaver,
Oh, yeah, he's great.
a professor who actually knows how to explain complex tech in a way that makes sense.
Exactly.
And he starts with this really simple but super powerful idea that communication is, well, it's fundamental to everything.
It really is.
Humans do it, obviously, but get this, data systems do too.
Yeah.
Just with, ones and zeros instead of words.
Ones and zeros, that's the language they speak. It's more than just wires and circuits then, right?
Way more. It's about bridging that gap between physical signals, like a temperature change, light, anything, and, well, us, our human understanding, turning those signals into actual knowledge we can use.
Makes you appreciate the invisible work going on all around us, right?
Totally. So how do we go from these simple sensors, hooked up to giant computers to, well, whatever's happening now?
Oh, it's gotten way more complex, that's for sure. You
Hmm.
see, early systems, they were like a one-lane road. Fine for a small town, right? But imagine that road trying to handle all the traffic of, like, New York City at rush hour.
Total gridlock.
Exactly. Crash, boom, system overload.
Okay, so how do we upgrade our data highway system then?
That's where distributed data acquisition comes in. Imagine a sensor network, but like a spider web, with each strand carrying data. But instead of funneling everything back to one central hub, we've moved, get this, mini computers right to the points of measurement.
Wait, so each strand of the web can process information, like, independently?
In a way, yeah.
That's really clever, but hold on. How do they all communicate if they're not reporting back to a central HQ?
That's where those standardized protocols he talks about in the article come in. Things like RS-232, RS-485, the whole gang's here. They're like the universal language for devices, making sure everyone's on the same page.
So we've got all these mini computers chatting away on our data spiderweb, but they all got to be speaking the same language to avoid, a digital Tower of Babel situation.
Exactly. And those protocols, they've had to advance right alongside computing power. Think about Ethernet, the thing you use at home for internet.
Oh, yeah, sure.
It revolutionized data acquisition by basically allowing these systems to piggyback on existing infrastructure.
So instead of reinventing the wheel, they just used a superhighway that was already there.
Exactly.
Pretty efficient. But the article, it also mentions even faster protocols like PXI and MXI3. What are those all about?
Yeah, so as impressive as Ethernet was, it did eventually hit its limits, especially in the super demanding environments. PXI and MXI3, they blew past those,
Yeah.
enabling data to travel at, get this, gigabits per second.
Okay, for those of us who don't speak fluent tech, how fast is that really? Like downloading a whole movie in a second?
Faster even. And that speed, it's not just about bragging rights. It's crucial because we've moved from like kilobytes to terabytes to petabytes of data in, like no time flat. This massive increase, it's brought us to a pretty fascinating turning point, actually.
You're about to tell me it's not about the speed anymore, aren't you?
Well,
You're right, it's not just about the speed. But hearing about all this data flying around at warp speed kind of makes me feel self-conscious about my own processing power.
I hear you. It's like we've built this system where we're gathering information, transmitting it, all faster than we can blink, but then there's us, our ability to actually make sense of it all. That's the real bottleneck.
Right. And the article even kind of hinted at this gap between the data itself and our understanding of it. So how do we bridge that gap then? We've got these digital superhighways, but we need some serious, I don't know, mental horsepower to actually keep up.
That's the million-dollar question, isn't it? It's like having a library, right, with billions and billions of books, but no librarians to guide you, no card catalog, and oh yeah, definitely not enough time to read even a fraction of them.
Okay, now that is information overload. So what's the solution? Do we start training our brains to think at gigabit speeds or something?
I'm afraid there's no easy shortcut there.
Hmm.
We need better tools for sure, and honestly, some new ways of thinking about data altogether. Think about data visualization for a second. That's where you turn those endless rows and columns of numbers into, well, something a human brain can actually grasp graphs, maps, interactive displays, that sort of thing.
So less staring at spreadsheets and more, what, visually exploring the data?
Exactly. We need interfaces that take this complex stuff and make it actually intuitive, allowing us to spot those trends, the patterns, just at a glance.
That makes sense. But even if we see the patterns, that's just the first step, right? Then what? What do we do with those insights?
Ah, well, that's where things get really interesting. That's where fields like machine learning, artificial intelligence, they really come into play. We can actually train algorithms to do the heavy lifting for us, sift through these mountains of data, find the hidden connections, even make predictions that would take us, lifetimes to uncover on our own.
So we're basically creating, what, like digital assistants to help us navigate this data deluge?
In a way, yeah. But these aren't just passive tools. They're actively analyzing the data in real time, adapting to new info as it comes in, even learning from their own experiences.
Okay, that is both incredibly impressive and also maybe a little tiny bit intimidating, right? Like we're creating a whole new form of intelligence here just to help us understand our own world.
And that's exactly why we can't just hand over the reins to the algorithms and call it a day. We have to be actively involved, you know, in shaping how this technology develops, how it gets used, all of it.
So it's not just about building faster computers, it's about asking the right questions about the data in the first place.
100%. We have to consider the ethical implications, right?
Mm.
Potential for bias, all of that, and make sure these powerful tools are used responsibly, for the benefit of humanity, not just because we can.
And that brings us to, so we've covered a ton of ground in this data acquisition deep dive. We started with simple sensors, then it was like, bam, algorithms that give a supercomputer a run for its money.
It really goes to show you, doesn't it? Human ingenuity. I mean, we're not just figuring out how to capture data at these crazy speeds, but we're teaching machines to help us make sense of it all. Wild.
Seriously, it's mind-blowing. But before we get totally lost in the zeros and ones, let's bring it back down to earth for a sec. What does all this actually mean for, well, for everyone?
It's huge, really. We're on the edge of, like, a whole new era of discovery. Think about it. Medical breakthroughs happening at warp speed, personalized medicine tailored to your own DNA, even cities that can, like, predict and prevent problems before they even happen.
Those are some pretty incredible, like seriously optimistic possibilities, but we also talked about some of those challenges, right? Like the ethical stuff, potential for bias, just the sheer volume of information. It's overwhelming.
Yeah, and we can't just ignore those concerns. That's why this thing, data literacy, it's more important than ever, I think.
Data literacy. Okay. Is that like, I don't know, learning how to code, but for data? What is that?
It's not exactly coding, no, but it's about, how do I explain it? It's about understanding how data is collected in the first place, how it gets analyzed, how people interpret it, recognizing its power, yeah, but also, crucially, its limitations.
So being able to, like, ask the right questions, critically assess all this information we're just bombarded with every single
You
day.
got it. It's about being an informed citizen, right?
Yeah.
Especially in a world that's more and more driven by data, we got to make sure this technology serves us, not the other way around.
That is a really powerful thought. So as we kind of wrap up this deep dive here, what's the one thing you hope our listeners take away from all of this?
Data, it's not just a bunch of numbers, It's a reflection of us, our world, our choices, everything. And as we unlock its potential, which we're doing every day, we have to do it thoughtfully, ethically, and with a really deep understanding of how it impacts our lives, because it's building the future, whether we realize it or not.
A future where hopefully we're not just, generating data at the speed of light, but actually using it to create a brighter, more informed, more equitable world for everyone. That's the goal. Thanks for joining us on this deep dive, everybody. And hey, remember, the most valuable data point in all of this is, well, it's you.